All right, we'll get back to section 10.1 here, and we're talking about parametric equations. Let's try another example. So we got x equals sine 2t, y equals cosine 2t, and suppose that t is ranging from 0 to 2 pi. Well, sine squared of an angle plus cosine squared of the same angle is equal to 1. So the angle here happens to be 2t. I'm using that Pythagorean identity. Sine squared 2t, that'd be x squared, and cosine squared 2t, that'd be y squared. So x squared plus y squared equals 1. And that's a unit circle, or a circle of radius 1. I'm centered at the origin, and I drew that circle there. Okay. Now remember that when you're graphing a parametric equation, you always have to indicate how you drew it out, okay, with arrows. That's going to be on every single one of these problems. Okay, so I'm starting at 0. Okay, so if t is 0, sine of 0 is 0, cosine of 0 is 1. Okay, so 0, 1, that's going to be my start point. And what if I let t be pi over 2 next? Okay, well, sine 2 times pi over 2, that'd be sine pi is 0. And cosine of 2 times pi over 2, that'd be cosine of pi is negative 1. Okay, so 0, negative 1, that would be on the graph. Now, I don't know how I get from 0, 1 to 0, negative 1, like if I went clockwise or counterclockwise. So I'd want to choose another angle between 0 and pi over 2. Like what if I let theta be pi over 4? Okay, well, if theta is pi over 4, 2 times pi over 4 is pi over 2, so sine pi over 2, that's 1, and cosine of 2 times pi over 4, that'd be cosine of pi over 2, that'd be 0. Okay, so the point 1, 0 would be on the graph when theta is pi over 4. Okay, so it looks like I'm going to go clockwise around this circle here. And now, if theta is 0, here's my start point. If theta is pi over 2, I'm down here. If theta would be pi, I'd be right back to where I started here. Okay, just to double check that. Sine 2 pi is 0. Cosine of 2 pi is 1. So 0, 1, that'd be on the graph. Okay, now I'm going from 0 to 2 pi, not 0 to pi. So what that means is that I'm going to make another revolution around this circle. I'm going to be tracing it out twice. Okay, I'm going to start at the point 0, 1 and move around the unit circle twice in a clockwise direction. That'd be how you drew out the curve there. Okay, and by the way, with some of these problems, you'll retrace over the spot that you've traced over one time. You know, you might do that several times or infinitely many times. Okay, just depending on the conditions for t there. Okay, so that'd be that graph. If we try another example here, suppose that x is e to the t minus 1 and y is e to the 2t. E to the 2t, that's the same as e to the t squared. Okay, so that's how I got y written. I got e to the t squared. And the reason why I did that is because if I solve this first equation for e to the t is x plus 1. So where I see e to the t, I'm going to go ahead and replace that with x plus 1. Okay, and therefore y is equal to x plus 1 squared. Okay, now that would be a parabola. Okay, but notice here that I'm not drawing the complete parabola. Okay, e to the t will always be a positive no matter what. Okay, no matter what I let t be. Knowing that e to the t is some positive number, e to the t, that's the same as x plus 1. So x plus 1 is greater than 0, or x is greater than negative 1. Okay, that would be the conditions on x. But so you know, for all these problems, by the way, you're going to have to know the conditions on x. You're going to have to know the conditions on x. So I will see people blindly draw a parabola, the whole thing, and then they got a wrong answer. So you always have to know the conditions on x there. Okay, so x is greater than -1. I'm strictly greater than -1, not greater than or equal to -1. So I'm going to want an open circle there at -1, 0. Okay, well, let's see, when I let t be 0, and I drew the graph of y equals x plus 1 squared, so I got a parabola that shifted to the left 1 unit. Okay, and again, I'm not drawing the complete parabola, but I only drew half of the parabola when x is bigger than -1. Okay, so then the next thing to do would be to see how this is traced out. Like, am I going to be starting after -1 and heading upward and outward, or am I going to be starting in quadrant 1 there and heading downward and inward? Okay, I don't know that. Well, if I let t be 0, then let's see, t is 0, it means anything to the 0 power is 1. So 1 minus 1 is 0 for x, and t equals 0 means I have e to the 0 is y equals 1. Okay, so I'll be at the point 0, 1 when t is 0. Okay, that still doesn't tell me how I trace this out completely, if I'm going this way or this way. Okay, so I probably want to select another value for t. Like if I let t be 1, for instance. If t is 1, I have e minus 1 for x. E is roughly 2.72. Okay, minus 1, that'd be 1.72. And then e squared is the y value when t is 1. Okay. E squared is roughly 7.4. Okay, so I'd be at the point 1.72, 7.4. That'd be up here. That's off the scale that I got. But that tells me how I've traced this out, because I'm selecting t equals 0, and then it'll be up here when t equals 1. Well, that means that I'm starting after this open circle here, because x is greater than -1, not greater than or equal to -1, and I've traced this out heading upward and outward. So I've indicated with arrows, how I've got that traced out there. Okay, so that'd be that graph. Here's another example. Okay, so what if I let x be cosine t and y equal secant squared t? Okay, well, secant squared t, that's the same as 1 over cosine squared t. And if x is cosine t, I have 1 over x squared be y. Okay, so I'm beginning this graph by drawing out the curve 1 over x squared. Now, 1 over x squared, the domain would be all real numbers except for 0. Okay, so I got a vertical asymptote at x equals 0. And now notice how I didn't draw this curve when x is bigger than 1 or when x is less than -1. Okay, well, that's because I know that cosine of t is always going to be a number between 1 and -1. That will always happen for any value of t, right? Now, x is cosine t. So that means that x has to be a number between -1 and 1. Okay, so that'd be the domain of this curve here. So I don't want the curve, heading out towards -infinity and infinity. I want to start when x is -1, and I want to end when x is 1. Okay, so I drew this curve heading up the y-axis there. Now, again, the last thing I'd have to do is to see how I've got this traced out. So I don't have conditions on x, or excuse me, on t. Okay, t can be anything. So if t is 0, cosine of 0 is 1, And 1 over cosine squared of 0, that'd be 1. So the point 1, 1 would be on the graph. Okay? And if I let t be pi over 4 next. Well, cosine pi over 4, that's 1 over root 2. 1 over root 2, using your calculator, would be about 0.707, around there, okay? And then if t is pi over 4, then 1 divided by cosine squared pi over 4. Well, cosine pi over 4 is 1 over root 2, adjacent over hypotenuse, right? And I'm squaring that, so that'd be 1/2 in the denominator. So I got 1 divided by 1/2 squared, right? Excuse me, 1 divided by, I already squared out 1 over root 2. So 1 over 1/2, okay? And when I flip the 1/2 there, I'll have 2 over 1. Okay, so here be the point 0.7072. Okay, and you'd be at that spot when t is pi over 4. And then you're going to continue. So it looks like you're going to start here, and you're going to continue to head upward. And now if t is pi over 2, I have x is 0, cosine pi over 2 is 0, and I can't divide by 0, right? So I'm going to have a vertical asymptote when t is pi over 2. Okay? And then if I let t be 3 pi over 4, well, cosine of 3 pi over 4 is adjacent over hypotenuse. That'd be -1 divided by root 2. Okay, or -0.707. And then y equals 1 divided by -1 over root 2 squared is 1/2. Okay, so 1 divided by 1/2, that's 2. Okay, so I'd be at -0.7072. Okay, I'd be at that spot there. And then if I let t be pi, well, cosine pi is -1. 1 divided by -1 squared is 1. Okay, so I'd be at the point -1, 1. Okay, and because I can let t be anything here, I don't have any conditions on t. You know, what's going to happen is, so you're going to start at this point 1, 1. You're going to come up the curve, and then after this asymptote, when t is pi over 2, you'll be heading down the curve, and you're bumping the point -1, 1. Okay, and then you'll head back up the curve, and then when you run into the asymptote when t is 3 pi over 2, okay, and then you'll be to the right of the asymptote, and then you come down when t is 2 pi. Okay, so you're going to end up tracing out this curve infinitely many times. Okay, so that would be the graph of that curve there. Okay, and I again, you know, with these parametric equations, like sometimes you'll end up tracing a curve, you know, 2 times. Sometimes you'll end up tracing a curve, you know, many times or infinitely many times, like we would with this problem here. Okay. So why don't we go ahead and stop right there in the notes, and I'll do these other problems in the next video. Okay.